Hello everyone, I hope you are doing good and staying safe. I welcome you all to yet another interesting tutorial by SimpliCode. In today's session, we are going to discuss about normalization in SQL. I hope my audio is fine and the screen is clearly visible. I see only a few folks have joined the session, so let's just wait for another 2 minutes so that we can have other people as well. In the meantime, guys, I would like to tell you that we have regular updates on various technologies on our channel. So if you're a tech geek in the pursuit of learning new technologies, consider getting subscribed to our channel SimpliCode to stay updated with all the latest technologies. And also hit that bell icon to never miss an update from us. So once again, guys, if you have any issues regarding the mic or the screen, do let us know in the comment section below. We'll try to fix it ASAP. So I see a couple of people have joined the session. I think we are good to go now. So as you all know, as a SQL developer, you often work with enormous amounts of data stored in different tables, right? So that are present inside the multiple databases. Now it often becomes difficult to extract the data if it is not organized correctly. So using normalization, you can solve the problem of data redundancy and organize the data using different forms. So this tutorial will help you to get know the concepts of normalization in SQL in detail. So without any further ado, let us dive into today's topic. So let me just present you my screen. Firstly, let us go through the agenda for today's session, guys. We'll start the tutorial by understanding what is normalization in SQL, and then we'll understand why do we need normalization. And after that, we'll discuss various types of normalization used in SQL, which are basically different normal forms such as first normal form, second normal form, third normal form, and BCNF, which is Boy's Code normal form. And finally, we'll wrap up the session by discussing some advantages and disadvantages of normalization. So without any further ado, let us just dive into today's topic. Alright, so what is normalization in SQL? Normalization is the process to eliminate data redundancy and enhance data integrity in the table. Normalization also helps to organize the data in the database, and it is a multi-step process that sets the data into tabular form and removes all the duplicated data, that is the repeated data in the relational database tables. Normalization organizes the columns and tables of a database to ensure the database integrity constraints properly execute their dependencies. So it is a systematic technique of decomposing tables to eliminate data redundancy and various other undesirable characteristics. Now, to better understand this concept, it simply means to bring something to its normal state. Now, from that, what I mean is the columns and tables are organized to ensure that the data integrity constraints are appropriately executed with their dependencies in normalization. So, normalization in SQL is mainly used to reduce the redundancy of the data. Since SQL is a language that interacts with the database to start any interactions with the data in the database, the data which is present in this database should be in the normalized form before it is processed further. So that's why normalization in SQL improves the data distribution in the database across. Next, why do we need normalization? Now, as discussed earlier, normalization is used to reduce data redundancy, which is the most important thing. So it provides a method to remove the following anomalies from the database and bring it to a more consistent state. Now, a database anomaly is a flaw in a database that occurs because of various reasons such as poor planning and redundancy. Now, there are various reasons such as insertion anomalies, which occurs when we are not able to insert data into a database because some attributes may be missing at the time of insertion. Next, we have updation anomaly as well, which occurs when the same data items are repeated with the same values and are not linked to each other. And finally, we have deletion anomaly, which occurs when deleting one part of the data deletes the other unnecessary or necessary information from the database. So that is the reason we need normalization. So if I put them into a nutshell, these are the main objectives of normalization, guys. So the normalization removes duplicate data and database anomalies from the relational database. It also reduces redundancy and complexity of database by clearing unwanted records or values in the database. It is also used to avoid creating and updating any unwanted data connections and dependencies. Now, if you're working on multiple tables, there may be a chance of unwanted connections. So normalization prevents that. It is also used to optimize storage space as well, guys. Now you don't want unnecessary or repeated values in your database tables, right? So to organize and optimize the storage space, we need normalization. And finally, isolation of data is also maintained. Now, a good design database states that the changes in one table or field should not affect each other. So this can be achieved through normalization. So these were some of the important characteristics of normalizations and why we need it. Alright, moving ahead, let us now discuss some different types of normalization in SQL. Now, there are 4 types of normal forms that are usually used in relational database, as you can see in the following figure. The first one is first normal form or 1F. Next, we have second normal form or 2NF. Next, we have third normal form or 3NF. And finally, we have Boyce Codd normal form. Now, actually, we divide the normalization process into a set of normal forms. So, a normal form is nothing but a form of a table that follows some, let's say, rules or regulations that prevent the above anomalies that we have discussed earlier to some extent. So, let us discuss about them in detail and see how they are different from each other and understand why they are important. So, first, what is first normal form or 1NF? Now, a table is referred to as being in its first normal form if atomicity of the table is 1. Here, atomicity states that a single cell cannot hold multiple values. It must hold only a single valued attribute. The first normal form disallows the multi-valued attribute, composite attributes and their combinations. I hope this is quite a bit confusing, so let us just understand the first normal form with the help of an example. So these are the 2 conditions which I have already discussed. That the conditions for a table to be in first normal form is that every table should contain a single value and each and every record must be unique. Alright, let us understand with an example. Now in the student table, let's say you can see the course column has certain values. So if you look at some of the courses and assigned to each student, we have more than one column. That is, the course column has 2 values, thus it does not follow the first normal form. Now if you use the first normal form to the above table, you can get the below table as a result. If you look at the side, the second table in that, we have basically divided the record into 2 parts. That is, Harsh, whose roll number is 1, who has enrolled in courses SQL and Java, which we are basically dividing into 2 records separately. That is, Harsh 22 SQL course and similarly Harsh 22 into Java. And similarly, we have for Kunal as well, who has enrolled for courses C and HTML, and also we have Sanya, who has enrolled for Python and SQL, which we have basically separated into 2 different records. So by applying the first normal form, you can achieve atomicity and also every column has unique values. So that was first normal form, guys. Let us now move into the next normal form, which is second normal form. So the second step in a normalization is basically 2NF or the second normal form, which is basically an additional layer added to the 1NF. So a table or a relation is in 2NF only if the table should be in first normal form, that is, it should satisfy all the properties of the first normal form, while the relation's every non-prime attribute depends on every candidate key as a whole. So it should meet all the rules and every non-key attribute is fully dependent on the primary key. So I hope this is a bit challenging and confusing. So let us again understand this with an example here. Alright, now the second normal form states that there shouldn't be any partial dependency. Partial dependency is nothing but if a proper subset of a candidate key determines the non-prime attribute, then it is called a partial dependency. So let me just explain you with an example here. Consider this student table here, which has student ID, project ID, student name and project name here. Now in the above table, if you look at clearly, we have partial dependency. Let us understand how. Now the prime key attributes here are student ID and project ID. And as stated, the non-prime attributes, that is student name and project name, should be functionally dependent on part of a candidate key to be partially dependent. I hope you've confusing between the keys, guys. So if you want to learn more about SQL keys, we have a dedicated and a separate video on our channel. So make sure you check that out. So coming back to the second normal form. So the student name can be determined here by partial dependent. So therefore the student project relation, the table violates this 2NF in normalization and is considered a bad database design. So to remove this partial dependency and the violation of 2NF, we have to further decompose this table in order to satisfy the property of second normal form. So let us now understand how can we do that. Now basically I am converting this student table into two separate tables, which is student info and project info. Now, the student info table has the student ID, project ID, and the student name, whereas the project info has project ID and project name. Now, a student name can be identified separately with the help of student ID. So, it is uniquely identifying every record of the student name using the student ID. Hence, the condition has been satisfied here, and similarly we have the project info. With the help of project ID, we can get the name of different projects that are allotted to students. So now the relation is in second normal form in the form of a database normalization using the second normal form. I hope you understood that, guys. So moving ahead, let us now understand what is third normal form. Now, it is a normalization level in DBMS similar to that of 1NF and similarly 2NF. So a relation is said to be in third normal form in SQL when it is in the second normal form, but no transitive dependency exists for a non-prime attribute. So let me just clearly explain you again. Now a given relation is said to be in its third normal form when it is in 2NF. That is, it should satisfy second normal form properties. That is, ultimately, indirectly, it should satisfy first normal form as well, but has no transitive partial dependency. Meaning, when no transitive dependency exists for the attributes that are non-prime, then the relation can be said to be in 3NF. So let's say in simpler words, if I say it should be in 1NF or 2NF, when none of the non-primary key attribute transitively depend on their primary keys, then we can say that relation is in third normal form of 3NF. So we can say that a relation is in third normal form when it holds any of the given condition in case of functional dependency that is non-trivial, where P, let's say X relates to Y, where X acts as a super key and Y acts as a non-prime attribute, meaning every element of Y forms a part of a candidate key. So let us understand this with a simple example, guys, so that you will have a clear understanding of that. So for that, I'm taking another table, which is employee ID, employee name, department name, city, zip code as its attributes. All right. Now the super key in the table mentioned above can be candidate ID plus candidate name, or else candidate ID, candidate name, and candidate, let's say, zip code, and so on. Now the candidate key here is basically the employee ID because it is uniquely identifying each and every record. So if you look at the non-prime attributes, all the attributes in the table mentioned above are non-prime instead of the employee ID, right? So notice that employee ID and the employee city that the employee belongs to are dependent on candidate zip code, and the employee's zip code and employee zip code is dependent on the employee ID. Here all the non-prime attributes like the city of the employee and employee's state are dependently transitively on the super key, which is employee ID. So the transitive dependency here would violate the rule of the third normal form. Thus we must move the employee's city and the employee's zip code to a new table of let's say into another table, which is zip info. So if you look at this resultant table where I have segregated the original table, which is the employee table, into three different tables here, which has the first one is employee info, which holds the employee ID, employee name, department as the attributes and its information. And in the second table, we have department ID and department name separately. And finally, I'm categorizing the cities based on their zip codes, that is into zip info table. So in this way, you can use the third normal form to perform the normalization using the 3NF characteristics. Alright, let us now move into the final normalization, which is BCNF. Now, applications of general definitions of 2NF and 3NF may identify additional redundancy caused by the dependencies that can violate one or more candidates key in a table. So, however, despite these additional constraints, dependencies can still exist that will cause redundancy to be present in 3NF relations. So this weakness in 3NF resulted in the presentation of a much stronger normal form called Boy's Codd normal form, or simply BCNF. So it was initially started, it was coined by Dr. H. Codd in 1974. So we will understand how this works. So it basically adds a more layer to our first normal form, second normal form, as well as the third normal form. So a Boy's Codd normal form is also known as a 3.5 NF, which is a superior or advanced version of 3NF and was developed by Raymond F. Boyce as discussed, which could tackle certain types of anomalies which were not resolved with the help of the third normal form. So the first condition of the table to be in Boy's Codd normal form is that the table should be in the third normal form, and secondly, every right hand side attribute of the functional dependency should depend on the super key of that particular table. So for example, for any dependency, let's say a relation x to y, x must be a candidate key or a super key. In other words, for dependency x relates to y if y is any prime attribute. So x cannot be a non-prime attribute. So now in general, if a table is in third normal form, it would possibly be in BCNF, and similarly like 4NF and 5NF as well. So we do not need much of BCNF. If we know what is exactly 1NF, 2NF and 3NF, we are good to go, and which is more than sufficient for a beginner level. So that was all about the BCNF, guys, and that brings us to the end of today's session. And let us now finally understand some of the benefits of normalization by understanding some advantages of normalization. Now, the first obvious reason is it reduces redundant data. Now, we might have a multiple data or multiple values in our database because of human errors, or we do not know what we are entering. So we might add additional files without our knowledge. So in order to reduce that, repeated values or unnecessary records, we need normalization. Normalization also provides data consistency within the database, and it is also more flexible, and it gives more flexible data design, which in turn gives a higher database security, and it is also better and quicker in execution as well. So that was some main advantages of normalization. And talking about disadvantages, there aren't much disadvantages to talk about. Like, since the data is not duplicated, we need table joins in more numbers, which would make queries more complicated, and thus read times are also slower. Since joins are required, the indexing of the tables also does not work as efficiently. Again, this makes read times slower because the joins don't typically work well with the indexing. So that brings us to the end of today's tutorial, guys. I hope you've understood the tutorial. So let us just wrap up what we have discussed. We have discussed about various normal forms such as 1NF, 2NF and 3NF in our tutorial. So in this tutorial, you have seen normalization in SQL in a glance and understood how the different normal forms of normalization. Now you can organize the data in the database and remove the data redundancy and promote and achieve data integrity. So in terms of if you're working on SQL databases, this isn't much an important concept, but this tutorial also helps for you if you are preparing for any interviews, which is a basic question which is asked in many of the interviews in various companies. So it is important to understand the concept of normalization in SQL. So I hope you understood this, and thank you for watching the video, guys. If you found this tutorial informative and helpful, please leave us a like and share it with your friends and colleagues. If you have any further questions regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to resolve all your queries at the earliest. I'll see you guys in the next video. Until next time, stay safe and keep coding.